Hello everybody and welcome to another C++ tutorial for beginners. Now in this video, I'm going to be discussing arrays. Now an array is a way to store multiple elements in the same variable or in the same kind of container or memory location. They are extremely important and you will learn more about them in this video, so let's dive in. So the first thing I want to say as we get into this video is that a list is not the same as an array. So if you're coming from another programming language and you've used lists before, really you've used anything that has the .append method on it or .push method or something like that, please make sure you are not mixing up what you know previously from other programming languages with what I'm going to show you right here, which is an array. Now they are very similar, a list and an array, but they also have some very important differences, and I just want to make sure that's very clear. Now, if you've never programmed before, or you've, I guess, never gotten this far in programming before, this is your first series that you're following along with, and you've never heard of an array or a list before, don't worry, I will explain them to you here, and you can kind of ignore what I just said, but just for anyone coming from another language, please make sure you really pay attention here because an array is different from a list. So anyways, what is an array? Well, an array is really a data structure, and that's really a fancy word of something that allows us to store multiple values that allows us to store multiple values. That's what an array does. So rather than having to define, say, 5 different variables, if we wanted to store 5 numbers, we can actually define an array, and this array can store all of those 5 numbers for us. So an array kind of looks like this. It's squiggly brackets, at least in C++ and other programming languages, it's square brackets. And inside of these squiggly brackets, you have a series of elements. Now, an element is really just a value of some data type. So it could be an int, it could be a float, it could be a bool, it could be a string, it could be a char, but in an array, all of your elements, all of the things inside of them are going to be of the same type. So they're all going to be int, they're all going to be float, all going to be bool, whatever it may be. But here's an example of a really straightforward array. We have 1, 2, 3 as the elements of our array. So what this allows us to do is store these 3 numbers in the order that we have them in, so we can maintain that 1 comes before 2, 2 comes before 3, and all of that. And then what we can actually do here with this array, and I'll show you how we do all of this obviously, is we can access each of these individual values or each of these individual elements. So let's say I want to change this value right here. I can fully do that. That's totally fine. I can also change all of the values in the array. The one thing that I cannot do, though, is once I define an array, I cannot change the number of elements that are inside of it. So I'm going to show you all of this. I know I'm getting a little bit ahead of myself here, but whenever you create an array, you need to decide the size of the array that you are going to create. And once you define that size, once you say that this array is going to have 4 elements, 5 elements, 27 elements, whatever it may be, you cannot change that size. If you wanted to, say, increase the size of the array, what you would actually need to do is make a new array, and you would need to copy the values from your previous array into the new array that then has a larger or smaller size depending on what you're doing. Anyways, hopefully this isn't confusing you too bad. I'm just giving you a high-level overview before we jump in here. I want to show you now how we create an array. So the first thing we need to do when we are defining an array is we need to pick what type the array is going to store. So this is a little bit confusing because an array itself is a data type, like an array is a valid data type, but inside of an array, we have elements, and those elements are a type. So we need to pick what type this array is going to be. In this case, I'm going to say int. So just like you would declare any other variable, you define the type of it. So in this case, it's going to be int, then the name of it, and then when you want to make this an array data type, you put 2 square brackets after the name of the variable. So in this case, I have int, ARR standing for array, and then 2 square brackets, and then I can do an equal sign, and I'll kind of code out the rest of this in a second. So this is saying we're defining an array. This array is going to store ints. Now, if I change this to char, what I've done is define a char array. This is because I have char here. This is an array, and so this array is going to store characters. If I change this to string, same thing. This is now a string array. So let's make it ints because this is the most straightforward. And now what I need to do is inside of these square brackets, I need to define the size of my array. So I need to pick in one way or another, I'll show you the other ways we can do this, how large my array is going to be. Is it going to have 10 elements, 5 elements, 4 elements? How many is going to be inside of it? So in this case, I'll just say 5. But you need to decide for yourself, and note that once you decide this, you cannot change it later on. It's not a huge deal. There's ways around this that I'll show you in later videos, but I just want to be very clear, you cannot increase or decrease the size of an array. Now, it's also worth noting that if I had, say, some value here, like int x equals 5, I could fully put x inside of here. And that would mean that my array is now going to be size 5 because the variable x stores the value 5. That is totally valid to do. And you'll notice, like, if you kind of experiment with stuff like this, you can do all kinds of things that you might not expect, especially if you've never programmed before. I could even do something like array and then, x plus 1, and this now is going to be size 6. So anyways, I'll leave x in there just for example purposes. And then after we do this, we have two options here. We can just declare the array like this, and we can say, okay, we're going to initialize what's known as an empty array, or an array that just doesn't really have any defined values in it yet, that is of size 5. Or what we can do is we can actually pick the elements that we want to go inside of this array. So if we decide to not pick, then we can just do this, and we've now declared an array. We've told the compiler, hey, allocate some room in our computer's memory to store these different elements. Or we can actually define the elements inside by putting these two squiggly brackets and then defining the different elements that we have. So in this case, I've created an array of size 5, and it has the elements 1, 2, 3, 4, 5. Now, if I tried to do something like 6, this would be an error. The reason this would be an error is because we cannot change the size of this array, which we've already defined to be size 5. By adding this element 6 here, that just, it doesn't make sense. We can't have 6 elements in an array that's only supposed to have 5. So this is how you define an array. We've now created an array. Now, it's also worth noting that when you define an array in this way and you actually pick the elements that are going to be inside of it, you do not need to explicitly define the size of the array. So right here, I've kind of gone a little bit overkill. I've said, all right, the size of the array is 5, and then I've defined an array that has 5 elements. But C++ is actually smart enough to know that if you just leave the square brackets like this and you don't actually put a size inside of here, but you do actually declare the elements in your array, it's able to just count how many elements are here and automatically create an array of that size. So now I can do any number of elements that I want, and C++ will what's called, I believe, infer the size. It's either imply or infer. I always forget which the meaning of those are, but I believe it will infer the size of this array by looking at the size that you've defined right here. So we'll just make this array size 6. Now, there's one more kind of sneaky notation here that C++ has. You actually don't need the equal sign. You can write it just like this. I don't know exactly why C++ has this, but this is the exact same thing as having the equal sign in. So just figured I'd show that to you. Like, these are completely equivalent, having the equal sign or not having the equal sign. Now, there's a lot of rules here. I apologize. We'll get into some more interesting stuff in a second. But if you decide to not actually define the elements in the array, then it is required that you add the size of the array. I cannot just do this. This is invalid. I do need to tell C++ in one way or another what the size of the array is going to be. So if I say int arr and then of size x, and we just do this, so it makes it equal to 2, 3, 4, 5, and 6. What I can do now is show you how we can actually access elements in this array. First of all, though, let me actually show you what happens when we just print out ARR. So cout ARR. Let's go here to the compiler. Let's compile and let's run. And notice we get some random gibberish showing right here. So why is this the case? Well, this array right here, what this really is this is a location in our computer's memory, in our computer's RAM, right? So whenever you run a program like this, like C++ program, your program is loaded into your computer's memory. And when you define an array, what happens is you're saying, okay, I want somewhere in my computer's memory these elements to be stored, or I want to allocate space for this array. So when you just print out ARR like this, what it's actually giving you here is the memory location of this array. Now, this doesn't really have to mean anything to you, but this is kind of where in your computer's memory this array is actually stored. So you can't actually just print out like all of the elements in the array as you might expect, at least not in this way. So if you want to access specific elements from the array, I'm going to show you how we can do that. So obviously it makes sense that we have these 5 values here. We want to be able to access each of them. I want to do something with the elements in this array. So there's something called positions or indices of elements in our array. Now, the indices or indexes start as following. We have index 0, which is the first element in our array. So if I want to access the very first element in my array, what I actually do is I write the name of my array, I write my square brackets, and then I write the position or the index of the element I would like to access, in this case, element 0. What this says is give me the first element that is in the array. I know it seems counterintuitive, but computers kind of always start counting at 0. So we would get element 2 here when we use index 0. Then the second element is going to be index 1. The third element's going to be index 2, fourth 3, fifth 4, and then I guess sixth would be 5, although we cannot use an index 5 here because we're trying to access an element that does not exist, right? If I try to access position 5, that's trying to get the sixth element in this array. This array only has 5 elements in it, and so this is going to lead to some kind of strange behavior, which I will show you later on. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is AlgoExpert. AlgoExpert is the best platform to use when preparing for your software engineering coding interviews. They have the highest quality coding interview practice questions with over 140 of them on the platform. With that said, check out AlgoExpert from the link in the description and use the code TechWithTim for a discount on the platform. Anyways, let me just show you here. When I do array and then at index 0, this is going to access for me the first element, which is 2. So it actually gives me this element 2 like that. All right, so let's change this now to just be, say, position 2 or index 2. Now a little quiz for you. Which element is this going to print out when I run this program? Give it a guess. Okay, so let's compile. Let's run, and we get 4. The reason we get 4 is because we're accessing the second position, which really is the third element in the array. Now, a little bit of a trick here. If you want to access the last element in the array, this is always the size of the array minus 1 index. So if your array has size 5, the last index in the array is always that size minus 1, which in this case would be 4. So that's how you access the different elements that are inside of the array. Now, if you want to change elements in an array, you can do this as well. So I can access, say, the very first element, and I can change this to be, say, 10. So now what happens after I add my semicolon here is I say, all right, array at position 0 or at index 0, I want to change this to be the value 10. So now if I print out array at index 0, you're going to see, as it would make sense, that this now is going to be, well, value 10. So that's how you access and, I guess, change the elements in an array. Awesome. Now let me show you what happens when we define an array, but we do not give it the unique elements, right? So if I just define an array and I say this is of size 5, what happens now when I print out the different indices of this array? So if I say cout array 0, and then I'm just going to kind of copy this down here. This isn't the best way to do this, but for now this makes sense. Let's print out all of the different indices, and let's do our kind of end L at the end of all these. Probably should have done that beforehand, but it's okay. So end L, end L. Okay, so what do you think is going to print out? Just give it a guess. You probably will have no idea, but let's compile the program and let's see what we get. Again, notice we didn't give the array its elements already. We just initialized that we have an array of size 5. So compile and run, and notice we get some completely random values printing out here. So this is kind of what happens in C++ when you do not define what is being stored in, let's just call it a container or in a memory location. You're just going to get a bunch of random gibberish. You have no idea what's going to be printing out. There's no way for me to tell you why exactly we got these values. It's just because at this point in time, this is what is stored at this location that we're trying to access in our computer's memory. You don't really have to understand this. The whole point is to realize that if you do not initialize the values of the array, you have no idea what is going to be stored in it. So just keep that in mind, right? Now, even same thing here. Let's see what happens when I try to access a position in the array that actually doesn't exist. So I try to access, say, position 7. Obviously, our array is only size 5, so there is no index 7. When I try to do this, let's see what happens. Let's compile. Let's run. Again, we get some random value. I can't tell you why we're getting that. All I can tell you is that when you try to do this, you get something completely unexpected that you cannot predict. So hopefully that's somewhat clear, but that is how you access the elements. That is how you change the elements. And that is what happens when you kind of create an array, but you do not give it the actual values inside of it. Now, of course, once we've defined the array like this, what I can do is I can say, well, AR is equal to, and then I can set it equal to whatever array that I want that has 5 elements inside of it. So I can say 1, 2, oops, let's get our commas right, 2, 3, 4, 5. And then if I see out here ARR at, and let's just go index 4, let's see what happens. So let's compile. And oh, what is it saying right here? Error assigning to an array from an initializer list. Okay, so it's actually a good error to run into. This is something that I didn't see when I was looking at arrays before doing this video. So apparently you actually cannot do what I just tried to tell you that you could do. What this is saying is that you cannot assign to an array from an initializer list. So this is what you call an initializer list. Don't worry about all the fancy names. And it's saying that since we've already declared this array, we've said that we have this array. I now cannot set the array equal to, and then this kind of array right here. I cannot do that. It's not allowed in C++. So if I did this, right, define the array in this way, and then I want to set all of its elements, the way that I would have to do it is by looking at each of the specific indexes. So if I want to set my array to have, say, 1, 2, 3, 4, 5 as its different elements, I would actually have to do the following. I would have to say array 0 is equal to 1, and then array 1 is equal to 2, and then so on and so forth. I'm not going to do all of them, but I'll show you now that we will get element 1 when I actually kind of declare or set the elements in this way. So let's compile, let's run, and see we do get 1. Now, obviously, this doesn't make too much sense to do it this way, right? Like, this is no better than just declaring a bunch of different variables. We still have to write all of this code to set all of the elements for our array. Now, I'm going to show you in the next video kind of some tricks to do this a lot faster. Right now, we just don't have all of the tools that we need to really make perfect use of an array. But I wanted to show them to you before, because then when I go into the next videos, you'll see why the things that I'm showing you are like really important, if that makes any sense. But anyways, that's kind of the idea behind an array. So there's a few more things I'm going to show you with an array. And the first thing that I want to do here is just actually define a new array. So let's make this 4, 5, 6, 7. Let's also make an array that's like a string array. So let's say string arr2, and then this can be equal to, or we can do it in this notation. We can say Tim, and then comma is, and then great, just to show you that we can have an array like this. We also could have an array that has float values. So float arr3 equals, or we could just do it this way as well. 1.1, 1.2, maybe negative 0.9, whatever it may be. You can define arrays in this way. Okay, so sorry for the abrupt cut. I forget what I said before I made the cut here. So I'm just going to quickly say, yes, we can define arrays of all different types. You can see examples here that I've written. Anyways, what I want to show you now is how you get the size of an array. Now, if you're coming from another programming language, you may think that this is very trivial, very easy to do. In a lot of programming languages, you can use something called .size or .length to actually get the size or the length of the array. The way that you do this is you would write the name of the array, in this case maybe ARR or AR2 or AR3, then you just do .size or .length, or sometimes there's a function, say in Python, you have this function called len that gives you the length of whatever structure you pass to it. Now in C++, this is not so easy. C++ makes things a little bit more difficult. Now to get the size of an array is kind of a two-step process. There is this function in C++ called sizeof. Now notice it's kind of highlighting a fancy color when I write it. Now what sizeof does is give you the size in bytes of an array. Now bytes, when I say bytes, this is like how much room on your computer this array is actually taking up. It's not the number of elements in the array, it is quite literally the size of this array in memory, like how many bytes are being used. Now the only good thing about this though is that if we know the size of the array in total, we know the number of bytes that are being used, if we're able to figure out how many bytes are being used for one element in the array, we can actually figure out how many elements are in the array. So typically when you want to get the size or the length of an array, you're asking for the number of elements in the array. That's what you want to know. So in C++, if you want to get this, what you can do is you can say something like cout, and then size of, and then you can say ARR. So this is actually the array, right? The array object. And then you can divide this by the size of one of the elements in the array. So if you know the array has at least one element, you can say, all right, well, the size of array divided by the size of array, and then this is going to be at index 0. So this tells you the size of the very first element. And the size of the first element is how much all of the other elements take up as well. So all of the other elements will have the exact same amount of space or exact same number of bytes that are being used by them. So by simply dividing the size of the entire array by one of the elements, this tells you how many elements are in the array. Now, there's a few other ways to determine the size as well, but they're a little bit beyond the scope of this tutorial right here. I don't want to get into anything too confusing, so I'm not going to cover them. But let's quickly just run this here and see what we get, and we get 4, right? So the reason we get 4 is because the size of this one element is something, the size of this entire array is something. We do the division, and since the size of all of the elements is the exact same, we know we have 4 elements, just some basic math. Now let's just see out actually the size of just the array, so we can kind of see what's happening here. And let's see out the size of the array at index or position 0. So let's go here, let's compile, let's run, and oops, I didn't mean to, I didn't want to do them beside each other. Let's do this again, okay. End L, and end L. Okay, let's try this now. Clear, compile, run. We get 16, 4, and then 4. So this is perfect. This is exactly what we wanted. This is telling us that the size of our array is 16. Number of bytes that it's using. The number of bytes that one element is using is 4. And so we have 4 elements in the array. Now let's just see what happens if we add a very large number as the first element in our array. Let's see if this still works. I want to compile and run, and notice we still get the exact same thing. So it uses 4 bytes to represent an integer. So hopefully that kind of makes sense. I can understand this part might be a little bit confusing, especially if you've never programmed before. Again, size in bytes. You want to figure out the number of elements. You take the size in bytes of the array and then divide it by the size in bytes of any number or any element, of the array. That tells you the number of elements that are in it. So I think that's all I really wanted to show you for arrays. Again, just keep in mind there's many different ways to define and declare them. Whenever you create an array, you cannot change the size of that array. I cannot add another element into this array. I would need to create a new one. You can change the value of positions in the array, and arrays start indexing at 0. So the very first element is 0, then 1, then 2, then 3. Again, the trick is the number of elements in the array minus 1 is the very last index or position that you can access in the array. So hopefully this was informative. Hopefully you guys learned something from this. If you did, make sure to leave a like, subscribe to the channel, and I will see you in another YouTube video.